So semiconductor is a class of crystalline solid with conductivity between a conductor and insulator. Okay. Compared to conductors, the conductivity is low, but compared to insulator, it can conduct electricity at certain conditions. Okay. So I will explain to you why later. So the conductivity is between conductor and insulator. Okay. The conductivity is better than insulator, but is compared to conductor, then it's much lower. Okay. Examples of semiconductors are silicon, germanium, boron, tellurium, and selenium. And the two semiconductors which are very, very important is the silicon and germanium. You need to know all this semiconductor, okay? But usually, okay, we will only discuss silicon and germanium only. These three we are not going to discuss. We will only discuss silicon and germanium only. You need to remember this because in an exam they may give you a list and then they will ask you which of the following are semiconductors. Okay, now then you should know. Let's see silicon. Okay, silicon or germanium. The structure is more or less the same. Just the number of electrons is not the same. Now silicon, it has 4 valence electrons, and silicon's 4 valence electron is not octet. Okay, octet must be 8, right? Okay, so silicons will share electrons with the other silicon atom so that it can achieve octet. For example, this silicon, okay, it has 4 electrons and then it shares 4 pairs of electrons with another 4 atoms. Then it will form 4 covalent bonds, right? You share electrons means you form covalent bond. So each silicon atom will form 4 covalent bonds. Okay, look at this one. Okay, because here actually there are another atoms here. Okay. Surrounding this silicon here, okay? So I just do not draw it out here. So there are atoms here and then form 4 covalent bonds. Okay, so each silicon it forms 4 pairs of 4 covalent bonds, 4 pairs of electrons, 4 pairs of electrons to form 4 covalent bonds. To form 4 covalent bonds, not 4 pairs. The covalent bond is 4 covalent bonds, 4 pairs of electrons, 4 covalent bonds. And this electron is not. They are not free to move, so therefore silicon cannot conduct electricity. Yeah, these electrons are not free to move. So the bonded valence electrons are not free to move. Okay, so silicon is not a good conductor at room temperature. Okay, all these electrons are not free to move. If a bonded electron absorbs heat energy from the surrounding, it may be promoted to higher energy level. We have discussed this in previous lessons, right? When we discussed thermionic emissions. We say when metal is heated, the electrons, the valence, usually it's a valence electron, will jump to another shell. Okay, so electrons when they absorb energy, they would jump to another shell. So for silicons, you see we have 4 electrons. This 4 electron is not free to move. Okay, but if you give energy to silicons, okay, then these electrons, it will jump to another shell. Okay, we jump to another shell. That is because the attraction force between the valence electrons and the nucleus or the core is not very strong. Okay, it's stronger than conductor, but it's not very, very strong. So therefore, if the electrons absorb heat energy, the electrons may jump to another shell. Okay, when they jump to another shell, the distance between the nucleus and the valence and these electrons increase. And if the distance increases, the attraction force will decrease. There's a force between these electrons. But the force decreases because the distance increases. So when this electron initially is here, when it jumps out to another shell, then it becomes free to move. Here, it's not free to move. Okay, but it absorbs heat energy. Okay, it must absorb heat. It absorbs heat, it will jump out to another shell and then it becomes free to move. Okay, so these electrons become free to move. Then it can conduct electricity. So therefore, semiconductor, it cannot conduct electricity at room temperature, but it can conduct electricity at higher temperature. Okay, if the temperature increases, then they can conduct electricity. But at room temperature, they cannot conduct electricity. That is semiconductor. Okay, the semiconductor. Because the attraction force between the valence electron and the core is not very strong, so the electron can jump out and then become free electrons. Now, after these electrons jump out, okay, it will leave a vacancy in this valence orbit. Okay, initially there's one electrons, right? Okay, so after this electron jump out, it becomes a free electron. So it will leave a vacancy here, and this vacancy here, okay, can attract the other electrons to go in. So the other electrons, maybe this here is the electron. These electrons can go into this place, okay, and this is called a hole. Okay, this vacancy is called a hole. So when an electron jump out, okay, it becomes a free electrons, and then it will leave a hole here. Okay, it will leave a hole here. So that's what happens. Okay, so that is free electrons and hole. Free electrons and hole. Now this hole, it can attract electrons. Okay, it can attract electrons. So therefore, we say the hole carry positive charge. Okay, because it can attract other electrons to go in. It can attract the same electrons to go in, or it can attract other electrons to go in. So the hole carry positive charge. So if temperature increase, the electrons absorb the heat energy, it jump out, become a free electron, and then it will form a hole at this valence orbit here. So that is free electrons and hole. A hole has a tendency to pull electrons. Okay, so as I told you just now, okay, it can attract electrons to fill the hole. So therefore, we assume that a hole carries positive charge. And both of the free electrons and the holes can help to conduct electric currents. So both of these free electrons and the holes are charge carrier. It can help to conduct electric currents. How? I will explain to you later. That is about the types of flow. Flows of electrons and flows of holes. This is a semiconductor, okay, silicons, and they conduct electricity. But if you heat this semiconductor, let's say these electrons, okay, so these electrons, it may jump to higher shell, okay, outer shell, and then it becomes a free electrons, and then it can move, okay, for example. So can you see that? Initially, the electron is here, okay, but if you heat it, then this electron can jump out. Okay, now jump out, it will go to the positive plate. Okay, you see there are two plates here, positive plate and negative plate. So this is this thing is inside an electric field. Okay, so the electron jump out, then it will go to the positive plate. So this is the flows of the electrons. No matter where the electron is, the electron here or here or here. So when it jump out, it will go to the positive plate. So it jump out, okay, and go to the positive plate, and then it will leave a hole here. The hole, it carries positive charge, and it will attract electrons. It can attract electrons from the surroundings. Let's say it attracts electrons from here. Okay, so you see what happens here. Okay, so you see the electrons from here, move into this hole. When the electron move into this hole, it fills this hole, okay. Then the hole disappear. Okay. And when the electrons jump out from here, go here, okay, then it will leave a hole here. So then you see the hole, initially the hole is here, okay, then the hole move here, right? So initially the hole is here, okay, let me show you it again. Initially the hole is here, okay. When the electrons from here jump to this hole, okay, so then the hole move here. The electrons jump back to the hole to fill the hole, and the hole disappears. This is called the recombinations. Recombinations. Okay, recombinations. Okay. Then the hole won't stop here because it can attract electrons from other places, right? Okay. So then, let's say the electrons from here, okay, go inside here. Then the hole. Now the hole come here already. Okay, the hole come here, and then, okay, again, the electrons from here go here, okay, electrons from here go here. Then the hole is here already. So you see the hole is moving. The holes move from here to here. After that, it move from here to here, and then move to here. Okay. So let's see how the hole move. Okay. So the process continue. You see the hole keep on moving. Okay. So you see the hole move from here to here, okay, to here, and then it move from here to here, and then move from here to here. Okay, keep on moving, and again, see the holes moving. Okay, so you see the hole move to this one, okay, after that it moved to this, after that it moved to this, and after that it moved here, okay. So when you reach here, okay, the negative plate has a lot of electrons, okay. So the negative plate can give one electron to the hole, okay, then finish, okay. So finish the lifespans of the hole, okay. So you see, the hole initially is here, okay, it moves and then go to the negative plate, okay. So this is called the flows of the hole. That's how the hole moves, the flows of the hole. And the hole carry positive charge, so it's a charge carrier. Electrons will move to the positive plate, okay. Electrons move to the positive plate, and the hole move to the negative plate. So there are two types of flow in a semiconductor: the flows of the electrons and the flows of the hole. Okay, so these two conduct electricity. So that is how the electrons and the hole conduct electricity in a semiconductor. Resistance change due to temperature change. So for semiconductor, as the temperature increases, more and more electrons are getting promoted to become free electrons, and at the same time creating more and more holes. Okay. Just now I told you that electrons, when they absorb heat energy, they will jump out to outer shell, and then they become free electrons, and they will form hole. Okay, if the temperature increase, more and more electrons can jump out and produce more and more hole. So when there are more and more electrons and more hole, then means that there are more charge carrier. So then they can conduct electricity better compared to a low temperature. So therefore, the conductivity of a semiconductor increases as the temperature increases. Okay, that's the difference between conductor and semiconductor. Conductor, temperature increase, the resistance increase. But semiconductor, when temperature increase, the resistance decrease. Because when temperature increase, more and more charge carrier, the electron and the hole is called a charge carrier. More and more charge carrier will form in the semiconductor. So therefore, they can conduct electricity better. So the resistance of semiconductor decreases as the temperature increases.